What I might do is insert a page. It's a bit easier. Okay. This is last year's HSC. 2020. Let P of x equal to x cubed plus 3x squared minus 13x plus 6. Show that P of t equals 0. 2 cubed plus 3, 2 squared minus 13, 2 plus 6 equals 0. Easy. Hence factor the polynomial where b of x is a quadratic polynomial, where b of x is a quadratic. Okay, so that means we're going to x cubed plus 3x squared. X cubed plus 3x squared minus 13x plus 6 into x minus 2. Now, a bit of revision from last year. I won't do the long division because I'm sure most of us will remember how to do it. We'll do synthetic division, just a bit of revision. So the way we do it synthetically is x minus 2, and you know the very first term is going to be x squared because you want x cubed. You know the next term, if it said factorized fully, didn't it? There's not going to be any yeah. So then this one here is plus 6 minus 2 times minus 3 is going to give you plus 6. I'm already 66% there. I just need to find the middle term. The middle term is going to be found by this guy here, 3x squared. You know that's going to be an x, right? So you know you want to get 3. How do you get 3? X squared. You're going to get 3x squared from negative 2x squared, this one, and this one, which we're going to call a. Does that make sense? So therefore a equals 5, and you're done. You factorized without actually factorizing. So the top, if you did long division, you guys should get x squared plus 5x minus 3. Happy days? 3 marks. Let me know if I'm going too fast, because I would like to finish this off if we can. For what values of A are the vectors perpendicular? For them to be perpendicular, we know that the dot product must equal to 0. The dot product must equal to 0 for them to be perpendicular. I think a topic that you would have missed a bit, Queenie, but we're going to revise it because I know I want to revise it for extension 2 as well. For what values are they perpendicular? So let's go up here again. We've got A1 and we had 2a minus 3 and negative 2. A negative 1, thank you. Dot product must equal to 0. How do we do dot product? X's plus y's. So 2a squared minus 3a plus negative 2 equals 0. Stop. Any questions? No. And then when you factorize this, you should end up with 2a plus 1, a minus 2. Therefore, a equals to negative half, a equals to 2. Yes? 5 marks so far we're at. What's our absolute? Is it 6? What's our minimum? I'll tell you right now, just so we can keep a track of this and see if we are already at a band 6. 70 marks. 70 marks. 70 marks. We need to get 78% of 70. We need to get 55. To get a band 6, we need 55 out of 70. You're only allowed to lose 15 marks. Okay, 15 marks. So we want 55. So we've got 6. We need 49 more. Let's keep our track here. So 55 minus 6 equals 49. Anything over that, obviously you're getting like 91, 92, whatever. All those are extra marks for yourself. Move. Number C. The diagram shows the graph. Sketch the graph of y equals 1 on f of x. Anyone remind us of what we did or what we would do? Asymptotes, where? Intercepts, thank you. There it is, and there it is. So far, you've probably got 1 mark. Then, I like it. You might be able to teach very soon. Big, small, small, big. So we know over here is going to look like something like this. And obviously this is going to be, and where do you think the third mark comes in? Third mark. -1 on 3. Very good. -1 on 3, 3 marks. We're at 49 minus 3. We're at 46. Go back. Greg, anyone, any questions? Look at the speed I'm working. It's the speed I want you to work at. Move. Actually, that's it. Every question 11 we're going to do from now on a speed test. Starting from next week. Now that I realize there's question 11 like this, we're going to do speed test. I'm going to aim for 6 minutes. 6 to 5 minutes. It's got to be bullet fast. All right, yeah, really fast. Bullet. By expressing this straight away, I know what to do for D. I'm going to write it up here. A equals √3 squared plus 3 squared, and then square root that. What's that? 3 plus 9, 12, √12. Somebody please check my working at the same time. Alpha equals inverse tan B on A. Pi 60 degrees. I keep everything in degrees for now. 60 degrees, and then that's it. It's done. So write it in that form. Actually, don't forget to do that. She's right. There it is. That's written in that form. And then solve. So √12 sine x plus 60 degrees equals √3. With me? Yeah. √3 divided by √12 and then inverse sine. √3. What about you, Ayel? Sorry? Which part? Which part? Seriously? I don't know too. That's what I'm asking you. X plus 60 equals 30 degrees. Which part? Well, how do you do? Yeah, do you know how to? Yeah, correct. Pythagoras. Square root a squared plus b squared. Done. √12. Inverse tan b on a. And then just write it. √12 sine x plus pi over 3. √12 sine x plus, and then once you've got that to solve this, you write this equals √3. If you're saying it's too fast, you've got to do 5 more yourself. 5, just 5 more, and you'll be like, it's the same question. Divide, inverse sine, you should end up with this result. What do we do now? We stop, we do all stations to central. 180 minus 30, 150. What do we do now? You're probably fine.
Yeah. I'll check 180.
No, that's T formula. T formula, check 180. Good point, but wrong one.
Actually, yes, you need to.
Not 180.
Add 360.
Add as many 360s and subtract as many 360s as you like. Remember that always. So we're going to add more. 390, 510, and I'm going to stop there. I think that's enough. X equals -30. That one's not even going to be an answer. So everyone would have just written 150 take away 60, which is 90 degrees, and then that's it. But what's the actual answer? We've got 90 and 390 take away 60, which is 330 degrees. And then the other one's too much as well. So the answer is a pi over 2 and 11 pi over 6. Greg, agree? 180s for T formula. Yeah. Queenie, you agree? Adding 360s and subtracting. Why didn't I subtract? Because I can see it says x plus 60. I know on the right hand side I'm going to be subtracting the 60. So why would I subtract when I'm going to subtract 60 as well? I should add 360, so then by the time I subtract 60, I'm back into my region. 4 marks. Escape, take away 4. Hey, we're getting closer and closer to 0. 42. Yes. Move. Solve dy dx equals e2y. Okay. We do this with our eyes closed by now. Equals dx. Integrate. Integral of dx is x plus c. 1 over e to y, don't accept it, make it e to the negative 2y. That becomes e negative 2y. The integrating, don't forget, divide by negative 2. Too fast? No, not fast. Okay. And finding x as a function of y. Oh, hey, that's not often. It says find x as a function of y, not the other way around. Finding x as a function of y. That doesn't make sense. It's just very poor worded. Because you know what it's trying to say? It's actually finding y as a function of x. Yeah, it's just very poorly worded. I can see the answer. It's very, very poorly worded. It doesn't matter. Finding x. So find x. X equals as a function of y. All right. Well, if it's x as a function of y, anyways, it's this, which is fine. That's 4 marks. There it is. That's x. As a function of y. But in reality, let's do the one we actually want. So let's do more than the question's asking us. Let's make y the subject for us. Yeah, no, but you know, finding x. If I told you go find y as a function of x, that's the idea. Yeah. So, anyways, times by negative 2. Bring the plus 2c over the other side. Log both sides. Divide by negative 2. Yep, perfect. Don't forget, you could have written the negative 2c as capital C. Don't forget, you could have written your negative 2c as capital C, capital A, whatever. All good? Move on. So what's that, 2 marks? Don't forget to add it. We're at 40. Do I really need to do the whole thing from the beginning for this one? Selection page. Okay, here we go. Change them to K's, just so that we can keep it consistent. That's step 2 done. Step 3. Step 3, prove n equals k plus 1, i.e. it's the whole question. Plus 1 more term, which is k plus 1, bracket 3k plus 3, but then plus 3 minus 1 is plus 2, equals k plus 1 squared, and then k plus 2. Just sorry for doing it really bad, but I think you guys get it. You would have written it a bit neater for yourselves. Agreed? Then, what does left-hand side equal? Left-hand side equals your assumption for all of this. So let's put that in green. That is my assumption, which is right there, which equals to that. So that equals to k squared bracket k plus 1 plus then whatever's left. K plus 1, 3k plus 2. I'm going to highlight what we're trying to get so you guys don't lose track of where we're going. Factorize k plus 1 out. I'm left with k squared plus 3k plus 2. Obviously, can we see it? Can we see it straight away? K plus 1, k plus 2. Yeah, so you just write it. I mean, done. Equals right-hand side, therefore true by mathematical induction. Done. Move on. Do it at your own time. Do it slower if you want to. I'm just trying to show you 37. Your weaknesses. And we're trying to find our weaknesses anyways. Binomial distributions, part B, I think that's meant to be what we're meant to learn. Yeah, not yet. That's going to be the topic that I've left. The topic I've left, we can't do that just yet. Very easy, like the expected value of E of X, 3/5 times 100. Finished. I. Like 3/5 is the percentage. How many times you're doing it? You're doing it 100 times, you just multiply, that's it. Variance is 100 times 1 minus 3/5. Easy stuff. But don't worry, we won't do it so I don't confuse you. So we won't add it to our tally. So we technically, right now, we say we've lost 3 marks. That's it. Let's think of it like that. We've actually lost 3 marks. We can't get them back. And that's fine. Sometimes you might have to do that. Right? You can't, if you feel like you can't perfect every single topic, it's okay. You lose 3 marks. Let's see if you can still get into a band 6. So let's continue. To complete a course, maybe we'll tally marks lost here. Marks lost 3. This one, pigeonhole principle. Oh, maybe you're good at it. Great, we'll do it quickly. If you're not good at it, again, you might say marks lost. It just really depends. Let's read it, because we don't even know what the question's asking. To complete a course, a student must choose and pass exactly 3 topics. To complete a course, a student must choose and pass exactly 3 topics. There are 8 topics from which to choose from. Last year, 400 students completed the course. Explain using the pigeonhole principle why at least 8 students passed exactly the same 3 topics. Okay, we would have done that, 7, done. Okay, so we would have done 8 choose 3. 8 different topics, you're choosing exactly 3. That can be done in 56 different ways. Last year there were 400 students that completed the course. So that means 400 divided by 56 gives me about 7.14. So you can see, and now you just got to write it in words. You can tell that there's going to be at least 8, but here it is in words. There are 56 different combinations for choosing 3 courses. If each combination has 7 students choosing them, that is 56 times 7. 56, which I kind of did my math up there. 56 times 7, becoming 392, right? So if there was only 7 students in each one, there would only be 392 students altogether. There are still 8 students left. Still 8 students left. No matter which combination these students choose, there will be at least one combination that has at least 8 students. Do we get that? And that's the pigeonhole principle. So one more time. If you want it in words, I'm going to send you the solutions to it. But if you want it in the video, I can write the whole solution. So let's go through it one more time. Okay. That's why I did it like this. 400 divided by 56, 7.14. That means there's definitely got to be at least some groups that have 8 people in there. But if I start it all again and we write all of our math from the beginning. So we said 8 choose 3 equals 56. And if there was 50, if only 7 people in every 7 people passing exactly 3 topics would equal to 56 times 7. So that means, what did we say? 392 people. So 392 people. But there are 8 students left. Sorry? At least one. Yeah. At least one. Yeah. There are 8 students left. No matter the combination, these students choose, there will be at least one combination that has at least 8 students. Make sense? Did we understand my logic when I also did 400 divided by 56? Do we know why I did that? Do we know how that shows me straight away there's got to be at least one, or not really? You prefer that way? Because I did it both ways. When I did my work in that last year, I did it both ways because it just depends on what kind of person you are. But if you feel like you're getting it, then great. Do we add those 2 marks or do we not add those 2 marks? You gotta be serious. Add it. Those 2 are saying yes. You're saying yes as well? I don't know. We might add 1 mark just to play it fair. So at least I'm giving you some room for error. So plus 1 here, minus 1 here. So we're at 36 so far. Okay, cos sine. Oh, that's an interesting one. You're thinking of a formula? Yes. So we need to scroll somewhere. Where is it? There it is. This guy. Cos sine. Cos sine is probably these 2. Copy to clipboard, go up. Page, append. Mariette, you going okay?
Yep.
Am I going too fast?
No.
Okay. So, cos 5x sine 3x. There's no such thing as cos n sine with double angles. You can't do it other than this formula. So, cos 5 sine, I'm just going to choose... I'll choose the second one. Okay. Obviously, you guys are thinking, oh, why was I even thinking? I was trying to go for the plus case, but didn't work out for me. You can, obviously, it wouldn't make a difference, but it doesn't matter. All right, 0 pi over 2. Cos is half. Put that on the outside. Sine 5 plus 3 is 8x minus sine 2x. Half. What's the integral of sine? Negative cos 8x on 8. Negative cos, so it means plus cos 2x on pi onto 0 half. Calculator. Cos 8 times 90 degrees is 1. Slowly, negative 1 over 8 plus cos 2 times 90 is negative 1. Slowly, look at the way, slowly. Cos 0 is 1, so that's minus 1 over 8. Very slowly, half. Lots of room for error, and we know it, that's why we choose it. Negative an eighth plus an eighth, I know we can cancel out. Minus half is minus 1. I think the answer I got just quickly is minus half after all of that. So quickly now, bang, bang, bang. Bang, bang, bang. 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 Times 0.5. I'm right. Done. Easy. That's what I meant by sometimes, you know, that pigeonhole principle, let's say. Just go and scab these marks at least. Like maybe it's a bit faster real quick. I don't know. You've got to work out yourself. As you should be doing exams now, I highly recommend doing them under speed conditions. Maybe give yourself, I think on Saturday I said 1 hour. Give yourselves only 1 hour now. So see how many marks you can get in 1 hour. You should get to, what's the score we're looking for? 55. You should get to 55 in an hour. You should. So a minute a mark, I think it's fair. And in the next hour, hey, you've got another 15 marks. You've only got an hour to do it. Go. Take it as long as you want now. So that's where we should be at. Hi. Exam here. Another. Wait. Grab this exam. Question 13. It's all recorded, so whatever you missed, it's on the recording.
Yeah.
Sorry, did I miss something? E, I did miss something. Thank you. Also 3 marks. Copy. So question 11 and question 12, easy. So far. Boom. E, find the curve which satisfies the differential equation and passes through the point. My God. Let's do it again. All right, here we go. Bring the dx over, bring the y over. We have y dy equals negative x dx. Integrate. I get y squared on 2 equals negative x squared on 2 plus c. Yes or no? Then you sub in x equals 1, y equals to 0, x equals to 1, y equals 0, therefore c equals to half. Is that correct? And we're done. It says find the curve. What kind of curve is it, you guys? 2? It's a circle. 3 marks. Oh, easy. -3. Did we subtract the other 3 marks before? I think we did. We're at 30 marks. We're getting closer and closer to the hard ones. Yeah, here's the working out if you need it. We're up to question 13 now. We just did 11 and 12 only. We have another multiple choice just yet. And we're tallying our marks because to get a band 6 we need 55. That's our mark out of 74, extension 1. 55, right? I remember the number. Yeah, 55. Okay. Question 13. Are we up to 13? Let's do it. I'll need more room. 5 marks. That's going to help us a lot if we can get this out. Insert. Bang. Okay, question 13. Differentiate sine cubed. Well, that's an easy I. What's the answer? 3 sine squared theta cos theta?
Yeah.
1 mark. Okay, next one. You know it. It's 4 marks. There's a trig substitution. It's going to be a bit annoying. All right, but let's do it. Okay, double I. X equals tan theta. Dx equals sec squared theta d theta. What's the next step? Changing limits. When x is 1, x is 0, theta equals inverse tan of 1 is 45 degrees, pi on 4. Inverse tan of 0 is 0 degrees. Any questions at this stage? Huh? Okay, slowly, very slowly, don't miss nothing. Okay, x squared. What would you replace for x squared? Tan squared theta. Tick it or cross it out. Maybe, yeah, just learn to cross it out. I don't know, it's up to you. Okay, maybe you want to do that strategy. That you crossed out your limits. Dx. What's dx stand for? Sec squared theta d theta. On 1 plus x squared. 1 plus tan squared. 5 over 2. What's 1 plus tan squared? Obviously. Sec squared. What's 2 times 5 over 2? 2 times 5 over 2 is just 5. So then the 2 and the 2 cancels out. We've got sec to the 5. What happens with the 5 and the 2? Too fast? Or you guys are getting where I'm at? Yeah. Oh yeah?
Wait, can you go back one step?
One step. We were here. We were here. Yeah. And then 1 plus tan squared becomes sec squared. And then you've got to imagine that's to the power of 5 over 2. What happens with the 2 and the 2? Pretty much those two cancel. Then you've got sec to the 5. What happens with the 5 and the 2? That gives you sec cubed, technically. You get it?
Yes.
As you practice this more and more, you'll get a lot faster with knowing that this whole thing is actually meant to cancel like that. Mariette, that was fine as well?
Yep.
So really, if you guys took a few more lines, you can, but really you should have ended up with this. Tan squared on sec cubed. 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 What happened? Tan squared on sec.
Oh.
What's wrong?
Nothing.
Tan squared sec cubed. Okay, what would you do now? 10, because look, let's be serious, right? We kind of know what we should have got. How do I know what we should have got? Nope, but how do I know? Why am I saying I kind of know what we should have got? Think exams.
Oh.
Say it again? Part I. So I kind of know that I was trying to get this. So then I can say the integral of this is back to sine cubed. That's the logic, right? Otherwise, why did they make me do I? So I kind of know what I should have got. I needed sines and causes. So guess what I'm going to do with this? Change it all to sines and causes. All right? I don't stop. I don't go, oh my God, tan squared on sec cubed. I don't know what to do. Just, it's kind of it gave you the hint. If you do exam questions, you'll understand that more and more. All right, move on. Back to this. Pi over 4, 0, just so we don't do anything wrong. I'm going to split them up like this. Sine squared on cos squared divided by 1 on cos cubed. And what happens when you divide by a fraction? Times and flip. Do I need to waste an extra line? So we can all agree that that's going to become cos cubed, and then that will cross out with that guy. And guess what we ended up with? Sine squared theta cos theta d theta. Nice. Is that what we had exactly? Very close. We had a 3. That's right. Easy to adjust. So I'll just write that in like orange or something here. We had y equals sine cubed, and we said y dash was 3 sine squared. So So therefore this one would become what when you integrate it? Well, a third, right? Because you're missing the 3 at the front. So it's a third of sine cubed theta pi on 4 and 0. Now you either sub in 45 degrees or pi over 4 in radian mode. Pick. I'm going to use, obviously, 45 degrees. I'll pause for a second. Now they're all good up to this stage. Everybody else? As well? All fine? Okay. So sub in 45. Sine 45 gave us 1 on root 2. Take the third out. Do this very slowly. This is the worst mark to lose by just simple algebra. Just take it, do it slowly. 1/3. 1 over root 2 cubed. And then sine 0 is 0, isn't it? So we're done. 1 over 3 times 2 root 2. If you're going to ask me, Sam, how did you get 2 root 2 from root 2 cubed? The only thing I can write for you, which I had told you before to memorize, x to the power of 3 on 2 is equal to x root x. X to the 5 on 2, x squared root x, and so on. I've got to give you a call around 8 o'clock. Thanks, bye. And then that's it, I think. Let me check the answer. Yeah. You can rationalize if you want. Whatever. All good? 4 marks? 4 marks. 4 marks. Not the same as the 4 marks we got up here, right? A lot easier, that auxiliary angle one. So that's why you need to get those. Those are easy. -4. We're very close. 26 left. You can feel it. Taste it. It's getting closer. The band 6, 90% in extension 1. Right, we're talking about just 90. I'm not talking about 91, 92. That's a little bit different. I'll explain what scores you want for that. Okay, find the volume. Another 4 mark. It's also going to help us if we can get it out. Anything that you've seen in this exam that we haven't done? Not really, right? You're saying like technically in extension 1, whatever theory you learn is technically in the exam. It's just, that's how that works. Same as extension 2. You learn a theory, advanced is the only one that's not going to be like that. So you just got to advance, it's going to be a little bit more open-ended. You're just going to walk in, you're not knowing what's going to happen. Just be ready for that. But the others, they should feel a little bit more comfortable. Should. If you keep practicing the way I'm trying to get you guys practicing. Okay. I'm going to start reading the question and stop talking. The region R is bounded by the y-axis, the graph of y equals cos 2x, and the graph of y equals sine x, as shown in the diagram. Find the volume of the solid of revolution formed when the region R is rotated about the x-axis. I pause. I think about, okay, volume. I try to remember my formula for that. Pi AB, if it's about the x-axis, dx, this guy is y squared. We have to remember that first. Yes? The region R is bounded by the y-axis. The graph y equals cos 2x and the graph of y equals sine x. Find the volume of the solid of revolution formed when the region R is rotated about the x-axis. What's the only thing I don't have? I don't have y squared, you're right. I don't have their point of intersection. So what's the first thing I've got to do? Cos 2x equals sine x. It's not going to say for you to do it, right? You've got to think of doing it. Cos 2x equals sine x. What's cos 2x equal to? Up to you, there's 3 of them. Which one are you going to pick? Good, because obviously you see sine, you would pick sine squared. 1 minus 2 sine squared equals sine x. Bring everything to one side, so you'll get 2 sine squared x plus sine x minus 1 equals 0. Factorize, you should end up with sine x plus 1. I see you nodding. That's good, right? That means, yeah, I would have kind of done this. I hope. Is that what you're nodding for? Yeah. 2 sine x minus 1. Then you end up with a few. You're going to end up with like a few solutions here, a few solutions here. Obviously, you're only going to choose the first positive one, which would have been at 30 degrees. X equals pi on 6. Let's put it in brackets, 30 degrees. Pi on 6. All good? Now what we need to do is obviously the y squared bit. So v equals pi from where to where? What's your y squared? Okay. Cos 2x, good point. Cos 2x minus sine x all squared.
Or do you want to like?
No, because it's rotated about the x-axis. Okay, let's talk about that. It starts with A. Does anyone know it? A and N, double N. I'm just going to say that. A double N. There's a word that is created when this R is rotated about the x-axis. And they're with respect to circles. So think of the circle topic, A double N, U annulus. That means it's going to become like a donut or a disc or a tire, whatever it is. Let's see if it's true. Think of something being rotated right here. Here's my section. Rotate about the x-axis. What's going to happen? Can you see it now? You're going to have a little gap in the middle. And how do we do annuluses? Well, the formula for an annulus is capital R squared minus R, little r squared. Does that make sense? So it's not what you said. It's not the whole thing and then squaring it. It's not what we're trying to do. We're trying to do it like this. What's the bigger radius? What would be the bigger radius? What would be the bigger radius? What's the y value of that? Sine x, right? Y value. So that is sine squared x. No, sorry, cos. It's this graph. You realize cos squared x minus sine squared x dx. Nada, what do you reckon? Okay, fine. Whatever you say. So top, we all knew it was going to be top minus bottom. I think we didn't have a problem with that, right? At all. We knew it was going to be the top minus the bottom. It's just working out what y value it would have been and then working out if Greg said all squared compared to this little squared. You've got to understand, is there a gap? Maybe that's why when I taught volumes to you guys, I always drew them. Because then I knew if there's a gap, straight away it's an annulus. Straight away, that's it. If there's going to be a gap like that, annulus. If it was rotated about the y-axis, would there be a gap? Look at it. If it's rotated about the y-axis, no way. Because it's touching already. Right? There's not going to be any gaps here. There's no gaps. It will be a solid. No gaps. You get that? I know.
Why would there not be a gap? Why then why is it?
Rotate about this line. Well, what's going to happen when you rotate? You're going to get something like that and another line. Is there going to be anything between it? No. But what happens when you rotate it? Let's say I said rotate it about this line. So rub out this blue. I said rotate it exactly horizontal, vertically still, about this line. Is there going to be a gap? Well, of course there's going to be a gap because when you flip this, it'll look like this. And there's going to be a gap in the middle. And here is the actual volume of this thing, right? So there's your middle bit, and there's your ending bit, and so on. So it looks something like that, but there'll be a gap because it's being rotated from somewhere other than where it's stopping. That's the logic of it. So it's like seriously, get up for a second. You'll see this. Get up, come stand next to me. So shoulder to shoulder. All right, we stand next to each other and we rotate. So you're gonna go backwards. See, there's no gap between us, right? But now stop. Now I'm gonna move here, and you stay there, and then I'm gonna rotate around you. What will always happen? There's always going to be a gap because we're not stuck together. But if we were stuck together in the first place, like this one is, stuck to the first place, rotate about the y-axis, there will be no gap. Then x-axis, there's already some gap. So by the time we rotate, there's definitely going to be an annulus. Makes sense? Good. Good. Question in your exam. The volume question, I can almost predict which one you're going to get for. It's going to be more of a 4-unit style question than a 3-unit style question. Because 4-unit volume got eliminated, they just put into 3-unit. So you want to do the harder 4-unit volume questions. So 4-unit does not have volumes, but you want to do the old 4-unit volume questions, and those will be the 3-unit questions you're going to get. I can almost guarantee. I can actually guarantee it, not almost. I can guarantee it because that was hard. Which that's 4-unit level, which means again it'll be at 4-unit level. Because all the other stuff like differential equations, auxiliary angles, you can't make them hard. This one you can make hard, so let's make it hard. That's going to be the logic. Anyways, we'll continue. How do we integrate sine squares and cos squares? How do we integrate sine squares and cos squares? Double angles, remember that? Yeah, so that's something that you're going to not forget. So I'm just going to bring it down here. V equals to pi, from where to where? 0 to pi on 6. Cos squared 2x minus, and just on the top here, we'll write our formulas. Cos 2x equals 2 cos squared x minus 1, and therefore from that we end up getting cos squared x equals cos 2x plus 1 on 2 on 2, and the other one you get sine squared half minus cos 2x on 2. You can't forget that. Obviously 100%, that's not even 99, 100% will be in your exam. From what I have been seeing, it's always been asked now in volumes. So expect it in volumes for sine squares and cos squares. But yeah, you guys can't forget that. So anyways, move on. Let's finish it off. Equals pi. What happens when you make it a 2x? You remember, you just double the angle. So it'll look like this. Pi over 6, 0, cos 4x plus a half, and then minus a half, we'll use brackets, minus half minus cos 2x onto dx. Pi, we're going to integrate. What's the integral of cos? That's actually positive sine on 8, half and half will cancel out, plus sine 2x on negative cos is, yeah, but I've got a negative in front of it, right? 2 negatives already made it a positive. All right, you said it's 30 degrees, huh? So 4 times 30 degrees. Sine of that, ugh. Why are you going to be annoying? Root 3 on 2, so root 3 on 2 on 8, plus sine 60. root 3 on 2 on 4 minus sine 0 is 0. Okay, that's all 0. So what do we get? We get pi root 3 on 16 plus root 3 on 8. And then you could obviously fix it up by times in 2. Times in 2. That's 3 root 3 on 16. That's the answer. Yay! I'm going to add 4 marks because I know with a little bit more practice, there's no issues with that one. It's not like perms and coms where you don't know. This one you definitely know exactly how you'll do every step. If you just practice maybe, again, 5 more or something. Okay. All right, last one for question 7 marks. Oh my God, we're at 22. 7 marks is pretty big for something that doesn't look that bad. So this is bad. Yeah, 7 marks. Okay. I've just got to think. I haven't read it yet, just wait. Question 14 is end of paper. All right. 7:03. Okay, let's go. Very doable in 1 hour. If I'm not talking this much, stopping, pausing, doable to get 55 marks in 1 hour. Suppose f of x equals, oh, okay, that's not bad. I thought it was just graphs. Suppose f of x equals tan inverse cos of x, and g of x is that. The graph of y equals g of x is given. Show that the derivative of f is the same as the derivative of g. How good are you at differentiation? If you say perfect, then you just got the easiest 4 marks ever. Let's say that. I need a page. All right. I need it up here. So f of x equals tan inverse cos, tan of inverse cos x. G of x equals root 1 minus x squared on x. Correct? All right, I'm going to start off with the g of x. I'm going to start off with g of x. G dash of x. Okay, what are we going to use? Yeah, quotient rule, right? U dash v. U dash v. Do we agree with that? Minus v dash u. Do we agree with that? Nada, what do you reckon? Over v squared. Over v squared. Do we agree with that? Now, we haven't done f dash of x, so I don't know. Maybe that might just become f dash of x. I don't know. You don't know, I don't know. So I wouldn't do much more. I would pause, skip like 5-10 lines. Just do that. And then do f dash somewhere down here. That's the truth. Like, what if we actually have it? I don't know. I don't know. So tan inverse cos of x. Okay, what's the derivative of tan? So we have sec squared inverse cos of x times the derivative of inverse cos of x, which is negative 1 over square root 1 minus x squared. Correct? Now, I would pause in my exam and be like, what the hell? How am I going to move from just x's, from g dash to trig? Surely impossible. Other than, hold on, other than drawing a triangle from trig to relate it to an algebraic expression, which this isn't. It's not saying like sec squared is equal to 5 over 4. Then I could have done something, right? It doesn't equal to anything. It's just now I somehow need to get rid of sec squared inverse cos into that. Come on, think with me. Tell me now. Don't make it too hard either. Don't make it too hard. Super simple. Just tell me what you're thinking. Sorry? Sec squared inverse cos x. What are you thinking? Change it to what? 1 on cos. So then maybe I'll just do it a little bit differently. I'll do it like this. 1 on cos x squared. Is that okay with you? And then, bless you. And then what happens with cos and inverse cos? They'll cancel. What do you end up with?
How many? Say you got up to that line. That's not that one before it.
That one there?
That's 1 mark.
1 mark for, I'm going to say for both of them.
Yeah.
1 mark for both. So now we know what we want to get, right? We need to get negative 1 over x squared, root 1 minus x squared. Do we have that? Yeah, no. But we know what we want to get, so let's do it. Let's go back up here. What happens? Half and 2 crosses out. Personally, when I see negative half here, this is how I did it even when we did geometrical calculus, like max-min problems, because very similar expressions in max-min problems. I would think of this as power of positive half, so that means that there's a fraction, and then you would have multiplied that up here. So in fact, this is what you end up with. Negative x squared minus 1 minus x squared to the power of 1, because a half times the half would have been power of 1, over x squared root 1 minus x squared. Too fast. No, wait. Queenie, too fast? No. Nada, what do you think? Too fast.
Is that
Okay.
supposed to be a half?
No, it's meant to be exactly as it says. So ready? You want to try to do it this fast because then it's just a bit cleaner for yourself. Okay, negative x squared, right there. Negative x squared is right there. You agree with that? This is to, if I want to make it into a positive index, it would have been divided by exactly this to the power of positive half. Correct? Positive half. Okay. So then if it's divided by positive half, I need to make it into a common denominator. If I want to make it into a common denominator, this to the power of a half times itself would be to the power of 1, because half plus half is going to equal to 1. Now I've got it all over a common denominator. All over a common denominator. Where is it? Right there. Does that make sense?
Yeah.
Now you do it slowly if you want. So you bring it down, make it a common denominator, and I'll wait for you until you get to this line. So you do it slowly. Scroll down. If that blue line was too fast, believe me, just do it slower and I will show you. I have to keep it there because really I need you to be there. I need.
Isn't it 6 squared, so it's 1 on cos squared?
I wrote that. That's why I wrote 1 over cos, inverse cos x, all squared.
Oh, okay.
But if you don't put cos squared still, you might as well make it all squared. Because you can't do anything with cos squared and inverse cos x. That doesn't make sense. Done? 4 marks. Hard, not the same easy 4 marks, I won't lie, but wait, sorry. Let's not say hard, because it's not hard. That wasn't hard. That was tricky. The other one, the volume one, maybe, yeah, your algebra, your calculus skills need to be better, like cos squared, sin squared, you need to know that. That, it was very easy, it's just tricky. Sneaky here, sec squared, inverse cos x. That you had to think the way I was making you think, like, what? Trig, algebra, they got to cancel out. But again, you've been exposed today. Hopefully, anywhere down your the next 20 weeks, if you see something like that, you'll think like that. How many marks do we need? 18. Using part I or otherwise, show that actually f of x is the same as g of x. Okay. Well, if their derivatives are the same, the graphs are the same. That's what it's trying to say. Show or otherwise show that f of x equals g of x. Well, if their derivatives are the same, when I integrate them, no, I can't exactly say that, right? What's the smartest way? No, not yet. No, not exactly. I'm trying to show you where the integral is. It is. I gotta actually define it somewhere. So hold on. So from the graph, well, I mean, okay. Okay. Let me show you what I would have written. What is g of 1 equal to? G of 1. 0. What does f of 1 equal to? Sub it in. Tan inverse cos x, tan inverse cos 1 actually also gives you 0. What does f dash of 1 equal to? Well, doesn't matter because it's going to equal to the same as g dash of 1. But whatever it does give you, doesn't make a difference. What does it give you anyways? F dash of 1. Doesn't matter, right? Doesn't really matter. It's going to be the same, actually. I don't know why it chose 1. Forget it. That was stupid. Hold on. G of 1 equals 0. F of 1 equals 0. F dash of x equals g dash of x. So any x values. Therefore, f of x equals g of x.
Is that what you do? Okay,
Let's check the marking guideline. That's what I would have done. Hey, I'm being honest with you. Me. Like, I don't think I would have mentioned much more than what I just mentioned. I'm not wrong with you. I'm not disagreeing with you. That's what I'm saying. I'm willing to check the marking guideline because I don't know what else I would have written. I would have said, well, the y values are the same and the derivatives are the same. So therefore, the graph must be the same. Let's see what they wanted though. Because surely they wanted something that I have missed. Happy? I'm willing to say I'm wrong. Extension 1 HSC math. Let's see. Marking guidelines. What question number is it, guys? 13. Somewhere probably down here. 13. A, B, C. Yep, done. There it is. If you want to see a little bit neater, see that becomes over. Then you would have multiplied it. Then that roots would have cancelled out, and then simplify and you're done. Does that make sense? Okay, let's see this part. Yeah, okay. Forget my answer. Observes that f of x minus g of x is a constant or equivalent merit. Perfect, we've done that. We've said f of 1 is equal to g of 1, which means it's always going to be a constant. That's not a problem. Provides a correct solution for one part of the domain or equivalent merit. One part of the domain, yep, which is what I did. Both parts of the domain, fine. True, I should have done the left-hand side. Okay, but let's say otherwise, f dash of x equals g dash of x, and so is a constant. For x is less than 0, so x negative 1, and x equals to 1. Oh, I was right. It's just that I didn't do it for negative 1. Fair enough, very easy. Do f dash of, f of negative 1 and g of negative 1. Do f of negative 1 and g of negative 1. They should have also been the same. Check it. Confirm with me. It is? They should have both equal to 0. Are they the same or are they actually equal to 0? Yeah, that's it. Easy. Yeah, that was 3 marks. But I would have lost a mark, unfortunately, because of my one domain. But I wouldn't have done that in my exam. I probably would have done both. Just double checking. Maybe do more if you want. Do 3, like whatever. I want to give myself 3 marks. Stuff it. Minus 3 equals 15. No, I know I would have done it. I would have done more. All right. Our favorite binomial. How many marks? 2 marks only. Okay, use the identity to show this. All right, I hope we remember this. We've done exactly this question as well, but let's think. Does anyone remember the expansion of 1 plus x to the 2n? The expansion of this. 2n choose 0 plus 2n choose 1x plus 2n choose 2x squared plus 2n choose 2nx to the 2n. Which one are you actually choosing? Which one are you equating? There's a trick to it. You have to look at the show. Do you remember it by any chance? Because you studied this pretty heavily.
I don't know.
Do you remember what coefficient? X to the power of what? There's a trick. It's in the show. X to the power of, nope. X power 0 is just a constant. So you wouldn't get all these things.
2.
Anyone? Queenie, you think you got it? No? The trick is this. You look at the left-hand side. It says 2n choose n. When are you going to get an n? No, 2n. You're going to get it at x to the n. So you're equating coefficients of x to the n. Does that make sense? Equating coefficients of x to the n. So for this one, what's the coefficient of x to the n now? In blue? 2n choose n. That's your left-hand side done. Make sense? Now we need to do the right-hand side, which I'll do in black. 1 plus x to the n. All right, what do you get when you expand this one? Say it. N choose 0.
And choose 1x. And choose 2x.
Now stop. All of this is going to be multiplied by itself again. Correct? Can you tell me in what situation are you going to get x to the n? This one with, which one? First one with x to the n. Remember, you're expanding this. Last one. Then second one with second last one. Third one with third last one, and so on and so on. Until you get to the last one here with the first one here. Does that make sense? Isn't n choose 0 the same as n choose n? So don't you actually end up getting n choose 0 squared plus n choose 1 squared plus n choose 2 squared plus ... plus n choose n all squared. You are done. You've proven it. Rings a bell?
Yeah.
Isn't it exactly the same question? Oh, you did a lot of it. Exactly. Yeah. All right. 2 marks. It's not hard. It's just about you knowing that it should have been coefficient of x to the n. How do you know it? It's all about this guy. It says 2n choose n. All right, minus 2. We're at 13 left.
You can do it if we finish though.
Sorry?
We don't need to do the multiple choice.
Yeah, that's what I'm trying to show you. If you can get through the short answer part, hey, multiple choice is bonus for you. Good, good. You understand. All right, and maybe even this question. Look, really hard binomial, 6 marks. You're like, oh crap. Oh well, leave it. Leave it for now. That's 6 marks we can't do as well. Marks lost. 3 plus 1 plus 6. 9, 10. Right now, yeah, we're working on our strengths. We're seeing if we had time limit, which I gave, like I said, 7, 1 hour, how many marks can you maximize? You can tell me, Sam, I can do 55 marks in 1 hour. You know in 1 hour you're going to get a band 6. Then the next hour you go for 91, 92, 93, 94, 95, 96. You get as many marks as you want. But we have to make sure we get 90 first. Let's do this. Question 14b, end of the paper. 4, 5, 6, 7. Unfortunately, we won't be enough. Where are we up to? 13. So we'll need to do at least 6 multiple choice from the looks of it.
Okay.
All right. Oh, if we obviously get this right as well. It's at the end, right? It's not going to be. It's not going to be here. It's easy. Again, how good's your algebra? Because you know if it's going to be the end, it's going to be serious, right? It's not going to be a basic one. Okay, I want to stop the recording.